Hello guys, welcome to my channel once again, and today I'm again going to solve some questions on the contest, and today we are going to give the contest. Oh shit, what was that? Okay, anyway, today we are going to give the contest 455. So yeah, so I hope I solve 4 questions because I have never solved 4. Okay, so first question is check if any element has prime frequency. Okay, what does that even mean? So you are given an integer array nums, return true if the frequency of any element of the array is prime, return false. And it's really straightforward question, to be honest. Oh, and also if you look at nums I, it's really very small, so I think this is the easiest question so far. I just need to check for 0 to 1, like the frequency can never be more than 100, right? So at max, so square root of 100 is 10, so I only need to check from 2 to 10, correct? So it's very easy. So what I'll do, I'll try to create a hash map which is something like it will look something like this, and maybe I'll try to have 101. Yep. Now for int x in nums, I'll be like hash, increase the counter on hash, and then for all the hashes I'm just going to brute force, right? Now what is the brute force? If I find a hash, then I'll check from j equals to 2. So first of all, if hash of I is equals to is less than or equals to 1, then it's definitely not continue, and do continue. But if it's divisible by any of the thing, then I'll just so yeah, this is what I'll do. I'll try to check if hash of I is modulo j is equals to 0. Then I'm like, no, this is really not working, so I'll also store a boolean bool check which will be initially false, and if this happens, or maybe it will be initially true, and if this happens, I'll be like check it equals to I don't think I should do this. If this happens, I am again going to just continue, right? Like, I don't really care about if it divides. Or maybe I should do it here. Yeah. Check equals to false, and then again yeah. So if it divides, I'm also I'll break it, and if not check, then true, else if I never find some check where check is false, then I'm just going to return wait, if check, then I'll do true, right? Because that's not really, yeah. Then I'll just return false. I think this should work. Yeah, first one is false, second one should be false. Wait, first one is false. How is first false? Four has a frequency of 2, which is prime. Okay. Right. Is less than equals to, actually this will be less than equals to hash I, right? Now we are talking. if yeah, true, false, true. I hope this works, or else I'll be that was an easy question. Like, I should have not have wasted so much time. Anyways, so you are given an one indexed integer array num way. So this is the one integer array where nums of I represent the number of ways to select a total amount of I using infinite supply. Is this a dynamic programming? It's literally a DB question. I don't know. Let's not come into a conclusion and try to see what's actually the question and then try to think. Okay, anyway, so nums of way I represent number of ways to select a total amount I using an infinite supply of some fixed coin denomination. Okay. So I think I get it. So nums of I represents how many, there is a fixed coin, some fixed coin denomination. Okay, what does that even mean? So there are some fixed coins, and how many ways I can, if I have an infinite supply of the nums I represent, how many ways I can make the amount I using those fixed coin denominations, and this is the number of ways. Each denomination is a positive integer with value at most nums of ways dot length. Okay, like, alright. However, the exact coin denomination have been lost. Alright, so I think each denomination is a positive integer with value at most. Okay. However, the exact coin denominations have been lost. And what does this mean? Your task is to recover the set of denominations that could have resulted in the given nums array. What? Okay, what the heck? Still sorted array containing unique integers. I did not understand the question, to be honest. What do I really need to do? Like, all right. There are two ways, number of ways. That the ways are 2, 2 and 4. Why not 1, 1, 1, 1? Why not that? Alright, okay, I think I got it. So basically I have some coins here, right? Okay, and now there is a fixed array. Okay, some array that I don't know. Okay, but initially there was some array of denominations of some fixed coins, right? And now obviously when nums of ways, this is just going to give me how, like let's say how many ways are there you can make 1, how many ways are there you can make 2, how many ways are there you can make 3, something like that. right? So I don't know the coins, but I do know this num ways. Now I actually need to find out the denomination. That's what I need to do. That's actually a very interesting problem. What is the constraint? Okay, num ways length is very small. Okay, I think I might be able to do it. So alright, so what can we do? So whenever I find out that denomination is 0, okay, so I'm pretty sure that that particular coin is missing. But if I find out that there is at least one, right, one way how you can make it, then I am happy. So let's say there is a lot of zeros, and then suddenly when you come here you see 2, and that's literally not possible. And one more thing, when you have a lot of zeros and then suddenly you see 1, then it is possible, right? It is something which is possible. But the point is that certainly if there is a lot of zero and suddenly there are 2 ways to now make the thing, now that is something which should be looked at, because that is not possible, right? So yeah, another thing also, like when it will not be possible, like let's say you have maybe a lot of zeros, and then you have 1, it is possible, but then whatever coin that you have, that when you try to find out what is how many ways you can make this amount coins using the coins, and it does not add up to the number, then there is again a problem, right? Then you will, okay, I think I got it. What should I do? Yeah, so like I can just make this thing, okay, vector, and yeah, int n equals to num place dot size, okay. So from this, so I need to make sum equals to 1, okay. Now how can I make sum 1? There are nums of ways, right? So if coin is empty, then I can just do nothing. Okay, yeah, so if I find out that that the number of ways that in a particular element, I saw that there are a number of ways, and the number of coins that I have already collected, and I try to figure out all of the ways, and I saw that it is really not how much, like it is very, there is a vast difference. Like this is the value here will be, the value that I got is num ways is way bigger than the value that it has. Then also we will have to, it's not possible, so we will just return that. So I also need to make initially, let's say it's true, right? Okay, so first thing that you need to make sum, okay, and with the denomination that you have on these coins. So how can you do that? How can you make this amount with the coins you have here? Interesting question, right? This question is, and you have infinite amount of coins. How many ways you can do it? So this question is actually a DP problem. What you can do is, so you have this sum, right? And let's say that you want to make sum, and you have this particular thing known as, let's say that the last coin that you were picking is let's say 2, right? Maybe the last coin is anything, but maybe some index j, right? Now what is this going to be? This is going to be dp of sum minus j, and j, right? Either this thing or additionally sum comma j minus 1, right? So when you know, either you reduce it by j, or, and this j is actually coins of j, right? To be honest, so it's just coins of j. So I'm like, okay, that's nice. This is how it should have been. So I'll introduce some DP thing, right? So identity, let's say len, which will be of coins dot size, correct? And now when will I say, what is the base case here? That's very important, correct? What is the base case here? So base case will be when sum is 0, correct? No matter what j you are in currently, it doesn't really matter. So it's just going to be 1, correct? If sum is 0, then it's just 1. Can sum ever be 0? My question. It's this thing. Okay. Well, I don't really know about that, but if sum is 0, then, but if sum is you know, okay, so let me also create a DP array here. Okay, maybe I should just add a vector here. Vector DP of maybe sum comma vector of maybe I should just do normally and DP of sum comma obviously it should be sum plus 1 comma len plus 1, right? This is what it's going to be. And now the base case which I'll do is this, correct? Now I will go from s, which will be initially okay, so like if you are to make sum equals to 0, how many ways of making sum equals to 0 with the 1, right? With index, let's say from 1 to j, whatever coin this actually is having, how many ways you can do that? So it's gonna be 0, right? So yeah, So for let's say j equals to 1 to j is less than equals to len, what I'll do, dp of 0 of j is just equals to 0, correct? Because there is no way you are going to have a sum, zero sum with some amount of coins that you have, correct? Or is my thing clear actually? Okay, so I think I'm doing something wrong here, so let me just change it a little bit. Let me do it something like this. If I have sum 1 to sum, okay, then no matter how much, if you are in 0, then you're just going to get demolished. There's no way you cannot just do anything, right, if you are out of the bound. Yeah, I'm thinking a lot to DP because this is not really my strongest subject, to be honest. So also initialize everything to 0, or maybe I don't really need to. So from j to sum, I can see that all of the sums are 0, right? And when you are at the end, this is also 0. So for j equals to 0, everything is done. Now we need to start from j equals to 1, correct? Because we can really see that for j equals to 0, it's done. So let's start from and j equals to 1 to j is less than equals to sum, right? J plus plus, okay. And in the same meantime, we can see that the DPA actually depends on the present j, but the previous sum and the previous j, right? So I can just do a for loop coming from the lesser value to the more value. In this way I can actually do everything. So initially this is going to be 0, and I don't know if what should I do with this. I have no idea. Like when sum is 0 and j is 1. Anyways, okay, s is less than equals to, well, this is going to be equals to sum and s plus plus. Okay, so this is what I want to do, but I don't know if this is actually going to work or not, because there's also certain things right here, like if coins of j is this is j minus 1. Yeah, so if coins of j minus 1, so let's call this thing x. If x equals to 0, so if sum is less than or equals to coins of j minus 1, then I will be like, okay, x is equals to, or this is also same thing as picking, right? Pick. So I can just directly write this pick for readability. pick equals to dp of sum minus points j minus 1 of j, and this is just not pick. I do not pick and I go with things. Yeah. Okay, so this should be the thing as far as I know. There is a certain problem with this thing that I am currently thinking, is that if sum is 0 and I is 1, then I can see that 0 of 1 is also just being pick, which will be, I think, 0 most of the time. Maybe this will work. So let's try to see if this will work or not. So dp of sum of len is just going to give me the ways. If this is if this thing is equals to the num ways of maybe let's say put this len minus 1, then I'll be like no, not len minus 1, it should be I. If this is something like this, then I can just continue, right? I can just continue, so I don't need to do anything. But the problem is when it is when something like this is happening, sorry, plus 1 is this particular thing, then I have to do something. Yeah. What do I need to do? So the main thing that I'll do is insert into the coins dot and place back the new coin, which will be I plus 1. This is what I'll do. Else well, sum is actually not going to be 1, correct? It's going to be sum is going to be what? Initially I plus 1, right? Yeah, that is what sum is. And if this is a thing, then I'll insert this thing. Else if this is greater, so if this is greater, ways or very any other thing, I'll just first I'll just continue this thing. It's sum and then this question ways of I, then I'll just continue, right? But if this is the thing, then I'll place like this. Else I'm going to say check equals to false, check equals to, or maybe like return false, sorry, return this thing, right? And it will terminate automatically. Okay, I think this is quite good start. So in the end, I'm just going to be like, okay, just give me the point selector. I hope this works. Sign it what? What do you mean? Okay, so this is. Oh, I'm not trying to assign. Here, one thing that I missed is this. Yeah. Okay, so a lot of mistakes are made here. I think this is alright, right? 246, which is the correct answer. 125, which is also correct. And 1 2 3 4 15, 1 2 3 4 15, which is really the correct answer. Okay, so wait, what happened? 125, 125, yeah. 246, 246. Yeah, this is correct. One thing that I want to make sure is like what is the time complexity. As you can see, length is never going to be more than, so it's like an n square, right? So this is okay. Yeah, this is going to work. Yeah. All right, let's talk about the third question. Okay, you're given an like I wasted a lot of time on the second question, really, to be honest. I shouldn't have wasted so much time. Okay, you're given an integer n, which is this guy, and you have an undirected tree rooted at 0. So I have a tree whose root is 0, and it has n nodes, number from 0 to 1 n minus 1. This is represented by the 2D edges of length n minus 2, which I can clearly see, and we can see that the okay, yeah, ui to vi, okay, but it's a tree, I don't really care. Each node I has been associated cost given by cost I, okay, represent the cost of the traverse, represent the cost to traverse that node. Okay, the score of a path is defined as the sum of all costs. Wait, what? Score of a path is defined as the sum of all cost or node along the path. Your goal is to make the scores of root to leaf equal by increasing the cost of any number of nodes by any non-negative amount. What? My goal is to make the scores of all root to leaf paths equal by increasing the cost of any number of nodes by any non-negative amount. Okay. Written the minimum number of nodes whose cost must be increased to make all root leaf scores equal. Okay. Alright, you're right. Quite an interesting problem this is. I have no idea how to do this, but I will try to think about this. Okay, so I need to find okay. What is the n is 10 to the power 5. Okay. I can actually make an LCA and then go to the LCA and try to reduce them. The main problem that I will face is, let me tell you, because this is not a binary tree, right? This will have, let's say I have some path, let's say I have some let me draw it. Okay, never mind. This, I don't know what I have to draw. Okay, so let's say that I have this node here. Now, okay, now when I try to okay, these are the leaves, right? When I try to modify this thing, all of these gets modified, right? All of these, the values of all these nodes changes. So whenever I try to do this, modify this, these leaves changes. Whenever I try to modify this, only that leaf changes. So the thing that I need to care about is that for each node, let's say for root, which leaves are really going to be affected, and that is what we need to find out. So okay, so how can we do that? Like obviously this root is actually going to affect everything. This is not going to affect. So at max, let's talk about what we can do at max. We will have the frequency stored somewhere, correct, of the leaves. Let's say more leaves are there. Okay, something like this is there. We'll just store the unique frequencies, and then whichever has the okay, how can we do this? I can just the cost of any number of nodes. Okay, I'll come back to this. Let's see what we have here. Looks like a giant question. Oh my god. Okay, there's some double shit as well. What the answer is in double? I can't believe. Oh man. You're given n individuals, a base camp who need to cross a river to reach a destination using a single boat. Okay, the boat can carry at most k people. Okay, let me I'll read this later, or maybe I should read it now. The boat can carry at most k people at a time, so at one time it can carry k people, and we have n people, but at one time we can only have k people cross, so in a boat. The trip is affected by environmental conditions that vary cyclically over m stages. Okay, that's nice. Each stage j has a speed multiplier. Okay, the trip slows down if multiplier is the speeds up. Each individual I has a rowing strength represented by time I. The time I takes time to cross in neutral conditions. Okay. Oh my god, this is just, why is it so big? Okay, let me try to think this and then I'll try to go there and think that. Okay, so like as we can see, the leaves are 1 and 3. I can just anyone I can just find and increase them. It's not a big deal. Okay. I can see that there is only one leaf, so 0. There are 3 leaves. I can just increase. Wait, I have to increase them. I cannot decrease. This is this thing is very good then. Oh wow, now we are talking. I can only increase, right? So I can just increase this value over here then. It's just, I can just make okay. Wait, it's still not over because this is 10. This is 9, right? I can just increase this by 1. So this not 1, I think. How much should I increase it for? This is 1. Oh yeah, nice. Okay. Okay, what is the rank right now? What? Only solving 2 questions and it's not really not good. Okay, I think I am getting this question a little bit more slowly. Okay, not this one. So I can only increase the values. So what I'll do is, I cannot obviously never look at the root. Now I'll see these guys over here and I'll be like, okay, tell me what which leaves do you control. So I'll have the maximum leave, like this guy, or whatever the maximum has amount will be with this guy, right? The maximum, right? And now if the overall maximum is lesser, then I am going to increase these guys, increase these guys by the amount of maximum, correct? So all of these guys will also increase its values, right? Whatever the maximum is. And now I'll talk to this guy over here, and overall maximum if it is equal, I don't need to do anything, and then I go back to this guy over here, and then again I'll have some maximum. Yeah, I can do this thing. That's interesting. This is an interesting idea. I think this will work. So let me tell you clearly what I'll do. So first of all, I'll go to the leaves, and this, I'll just sum the path up, okay, and in this subtree, whatever the path, this path will have some maximum, so I'll give the maximum to this guy, and this guy, and now I'll go there, and whatever the maximum I got from these guys, I'll give it to this guy, right? and then similarly whatever the maximum from these guys, I'll give it to this guy. So I have the maximum leave paths, right? I have the maximum paths, leave paths, and here also whatever the maximum I get from these guys, I'm just going to take the maximum. That's not an issue. Okay. Now I need to, what I'm thinking is that I'll go to this guy at first and see if the root's maximum and its maximum, this guy's maximum, is equal or not. If it's not, then I'm going to increase the counter here. Okay. So every value is going to be increasing its numbers, right? And now again I'm going to check their sub values and see if because I've added 4, like I'll add 4 to these guys as well, and then check if still whatever the maximum this guy has, is this guy also okay. I think I got this. I will be able to solve it. First of all, I will do a DFS which will give me the costs. So I'll need to make the graph. Yeah. G for vector and P of edges, I will land U is equals to P of 0, V equals to P of 1, and G of U is press back V. I can also do the other way as well, but I don't really need to do that. Zero to 1, 0 to 2. Okay, so it's done. Now I'm going to do this. As is cost, I'll have the sum of the leaves, right? And I'll increase the counters. I can't do this, guys. I literally can't do this. I just need to think harder. Okay, so first of all I need to save the maximum. So I need to make a, let's say, maximum vector maximum, which would be initially okay. So costs are of 0. Okay. Okay, I don't think I need to do this. Maybe I can just keep it here because of I'll tell you why. I don't really want to pass to the function again and again, so that's why I kept it here. Assign this to 0. Yeah, now I'll do the DFS. Int DFS, but don't return anything. Let's do it in the void. And I also don't want this. I should keep it here. G dot endless back vector int. And why am I doing this? Assign nice. Okay. This is good. Actually, you know what? I don't want to do this over and over again, and the syntax is wrong. Anyways, what I'll do instead, I'll be like this. Oh no, man, better with this one. Okay, cool. Just U is enough, but the cost, I need this cost. Vector int and C maybe. Okay, right. Now what I'll do, I'll just go to the children, and I know I don't need to keep a parent here because of obvious reasons. What I'll do, okay, let me also create a sum here, which will be I think 0, or what do you think should be? Sum should be 0 or what? DFS of B, C, sum plus C of B maybe, right? B or U? Is it U? I think B. Here I'll explicitly write this one. Okay. Anyways, when I do this in the same time, I'll be like max of U is equals to maximum of U, comma maximum of V. Correct. Okay. And first I'll do all this. First is sum, and then when I reach here, I'll do this, whatever the maximum from the TFS from V, give it to me, right? I think this is all right. In the end, yeah, this is quite great. Like maximum of U will be again and again compared with V's, and get what you want from maximum of these guys. Max of these guys. Yeah. Okay. I'm done with the first DFS, and now the second DFS, I'll have a counter. So let me also call the DFS 0, cost, and cost of 0. Alright guys, now we are talking. It's almost like lazy trees, if you know the concept of laziness. Anyway, now what I'll do this thing. Okay, after I got the maximum for all of these guys, I'll go to these guys and I'll see if whatever the maximum this guy has, is it equal to the maximum here. If it is equal, maximum here, I know what is the maximum, correct, in this subtree, and what I have to do is if I can see that the maximum of these guys is maximum of these guys over here. What am I even doing? Okay, I have some maximum and I can see that the maximum of these guys are equal to this maximum. Then I'll just go there and try to solve the problem. I will not increase the counters, right? But if I find that the maximum for some case is not equal, right, then I'll increase the counter by that counter. Okay, so I think this is straightforward. So for this thing I also need a counter which will actually count how many nodes I increased, right? So here I found out that the maximum here I cannot improve this guy. So okay, but I can see this maximum is equal. I can see this maximum is equal, but I can see this maximum and this maximum, the maximum here, whatever the value I have here and whatever the value I have here is not equal. Then I'll again increase the counter and go there. This is what I'll do. So yeah, so I'll do something like this. DFS, I'll have a counter, so anti counter. Okay, I'll have this U. I'll also have this maximum which I already have, and I'll have this counter again, and I am also going to store a sum for each of the values. This will tell me if the sum has increased or not, or something like that. Initially the sum is 0, I just don't need to do anything, and I'll check if for 93 in G of U, I'll be like, okay, is the maximum of U is plus sum. Not equals to maximum V plus sum. if this is the thing, right, if this is the thing, then I will improve max u minus max v as sum. So I'll do something like this. I'll increase the counter at first. So counter plus plus, and then I'll make it just simply do a DFS. U count and sorry, this will be, and the sum will be sum plus maximum of u minus maximum of v. Whenever it encounters this, it will increase the sum by that amount. So the sum is now this thing. And now again I will just try to do. So let me call this DFS2. Right. I will be like DFS2 of 0 of count of anti-count equals to 0. Return count. This should work. This is 1, 0, and this is 1. It is working. I don't know if it will work for. It's giving me a runtime error. Wait, what? So cost I times, what the hell? So I need to make this long maximum also, long count is alright. What else? Now I think it should work. Did it work? Okay, I just play. Okay, it didn't work. What the hell? Why didn't it work? One to 0, 0 to 2. What is this thing? What the fuck, man? That's why. Okay, not good. This is literally not good. P. Next time I'll always if v is not equals to p, then u, whereas so u, here I have to have -1. It's not, I don't like this really. Okay, yeah, that's how we do these questions, guys. Now we have the last question, and you're given an individual. Oh yeah, I already read a little bit. I need to start from here. Okay, so a group of G departing at stage J takes equal time to the maximum. What the fuck, man? I'm literally having this some kind of fatigue in my brain that is making me unable to read any of the question. It's not going inside my head. Like, it happens a lot, especially when you do some hard questions and then the next hard question it doesn't work. Got 2 penalties, man. Alright, a group of G departing at stage J. What does that even mean? Each individual I has a rowing strength represented by time and unit it takes to cross alone in the neutral condition. Okay. Alright. I got this. A group G departing at stage J takes time equal to the maximum time I. Like, imagine, like I'm thinking about the previous question for a while, because imagine if like this was the wrong answer, right? Imagine if this edges was so much long, I wouldn't be able to figure out why this was wrong. I would have thought that my algorithm was wrong, and like that's like the question clearly says that this indicates an edge from UI to VI, and like I literally wouldn't have think that it also means VI to UI there is an edge. Anyways, okay. I hope I solve this. Just 4 questions. Okay, so let me see my rank as well. How much rank? Alright, it's alright, I think. Okay, so a group G departing at stage J takes time equal to the maximum I among its members multiplied by mol J minutes to reach the destination. Oh my god, I have no idea what it's talking about. I literally have no idea. group G departing at stage J takes time equal to the maximum time I. Group G, where the fuck is group G, man? Somebody tell me, where is group G? Like, what is group? If it's departing at stage J, and where is the fucking stage? Somebody tell me, like, what are they talking about? A group G departing at stage J. What am I supposed to interpret from this? Okay, let's say that these are the time taken by some of the, let's make our own group. Let's assume, try to interpret the things by ourselves. So let's say that there are numbers written on the people, and let's say there is a group where these guys are, on the boat and trying to go to the destination. Okay, now it is departing at stage J. Okay, now this is something that I have no idea what it's talking about. Like stage J, let's what is this M? Do I know what M is currently? M is modulo, for modulo, just for modulo. Floor D modulo M, what the okay, floor D, yeah, us. Okay. Individuals left behind, one person must return the boat. R be the index of the returning person. Okay, so if they let's say this, if they start at what is mul of G? Each stage. Okay, here is the stage. What is the size of multiplier? Oh, it's M, and multiplier is it can be twice speed, or it can be half the speed. It can half the speed. Alrighty right. Okay, I think I'm getting to understand this question. Okay, so if the M is moved at length, multiplied at length, then what, like, how do we know which stage is it talking about? Like stage J means what? Okay, so let me think about it. So if the stage is at 0, then the time these people are going to take will be whoever has the maximum time, which is this, multiplied by the stage J. This much time it's going to take to reach the destination. Okay, after the group crosses the river in time D, so let's say that the time is D, which is just literally time of I. times mul of j, and this is just going to be max of this these people's time. Okay, anyways, max of people's times bulk. Okay, after the stage advances by this many steps. Okay, what the fuck. So after they reach this time, they will the floor D, and then so basically this is going to be it. If the individuals are left behind, one person must return with the boat. If the individuals are left behind, one person must return with the boat. Let R be the index of the returning person. Okay, return the minimum total time required to transport all the individuals. If it is not possible to transport all individuals to the destination, return I. Okay. Oh my god. Okay, so like how do you know when, like, what is the starting stage? How do you know what's the starting stage, guys? Is it do we have to assume that to be 0 or what? In the constraint it's not given. Okay, I have no idea what it's talking about. I have no idea what it's talking about. Okay, ठीक है. ठीक है. The minimum total time to required to transport all individuals. Oh shit. Why can't I just make all individuals sit here and then just make them go to the destination? Why not? Why can't I do that? Oh, okay. Okay, so one thing is clear, I think. If for the first time, when if the multiplier is actually 1, then I can just make every 1 or more greater than equal to 1 for the first time. I can just take everybody and take them and go to the destination. If for the first time multiplier is less than 1, then we are a little doomed, right? But still I can just take everybody, make them sit here, just make them go, right? Why can't I do that? Because maximum time times maximum time. Oh shit. Because the maximum time also multiplied by. So if multiplier is half, okay, I got it. Oh man, this thing is, I literally cannot think this. I need to look at how to solve this. Like, I literally don't have anything in my head right now. All right. What can we do? What can we do? Like, there is no way I can do without DP. Like, I'll not believe that we can do this without DP. So first of all, I can just sort the time initially. I don't know if the time is already sorted or not, but I'll sort the time. Sort time dot begin, time dot end. Okay. Now what I'll do, I'll tell you what I'll do. So this, I think this is a DP question. So I'm thinking of DP states, and okay. Yeah, okay, so DP of I and stage, maybe stage, can I use stage? I don't know if I can use, yeah, I can use stage. Okay, so one more thing that I can see is that its time is very less, like the length of the time. So n is almost like 12, so I should be able to do this really. How can I do that? So let's say DP of I of stage J. Wait, so initially what is the stage? I am not, like, I have no idea. Is the stage 0 initially? Okay, whatever the stage we have. Okay. Man, this is so hard. Because the guy who is going to take the less time, he should be the one, coming and going, right? Guy with the least possible time. Anyway guys, I don't think I will be able to solve it in 4 minutes. So yeah, I hope you enjoyed. I know that you will. Like, how will you enjoy this? Even though if you have enjoyed, I don't know if you have learned something new or not, because I was just not even telling what I was thinking properly. But still, if you watch this video, I'm grateful that you did. Okay, anyway, bye bye guys.